Hi everyone, this is composite functions. So a composite function can be described as a function within a function, and we often write it in either of these two notations. So an fg of x or f little og of x, and we actually sometimes just abbreviate that to fog or fog. You will see both notations in the IB exams, so you just got to be familiar with both. Now what both of these representations mean is that the function g of x will be put into the function of f of x. So g goes into f. A little tip here, you must always apply the function nearest to the x first if you're putting in values, and you'll see how that works soon. First example here, we've got the function f of x equals 2x minus 3 and g of x equals x squared. We want to find f of g of x. Now because g of x is inside the brackets of f, it means that one has to go into f. So this one will just be 2, and instead of x, we now write g of x, which would be x squared minus 3. And then we can write that without the brackets. Then b, we want to write g of f of x, so this time we're going to put f of x into g. So wherever there's an x in g, we write the whole f thing instead, so that would be 2x minus 3 all squared. Example 2, we've got f of x equals 3x minus 5, g of x equals x squared plus 2x minus 1, and h of x equals a negative 3. Part A, find f of g of x. So g of x in the brackets, so we put g of x into f wherever there's an x. So f of g of x equals 3. Now we've got 3x, so instead of x, we now write g of x. So it'll be 3 multiplied by x squared plus 2x minus 1. Then we have our minus 5. And if you wanted to, you can tidy that one up by expanding the brackets and simplifying, but it's not always necessary. Okay, B, we want g of f of x. So that means we're going to put f into g. Whatever the letter's second goes into the first letter. So wherever there's an x in g, we're going to put f. So we'll have 3x minus 5 all squared. We have 2x, so it's going to be 2 times 3x minus 5, and then minus 1. Once again, we can simplify that if we need, but I'm just going to leave it like that for now because we're more wanting to see that we can substitute into the correct parts. Part C, we want f of h of x. So now we're putting h of x into f. So wherever there's an x in f, we're going to put h of x. So we're going to be 3x, so it's going to be 3. Now h of x is just negative 3, so it would be 3 times negative 3 minus 5, which should be negative 9 minus 5, which equals negative 14. D, we want f of g of negative 1. Now there's different ways you can solve these. I'm going to show you both ways. I'll do it in 2 different colours. So the first way is, you see in part A, we already found f of g of x, and so it would just be to put negative 1 into that. So we'd have 3 multiplied by negative 1 squared plus 6 times negative 1 minus 8, and we can work that out. So it'd be 3 minus 6 minus 8, which is minus 11. The other way we can do this is actually to put the negative 1 into g first. So we're actually first of all going to work out g of negative 1, which will be negative 1 squared plus 2 times negative 1 minus 1, which equals minus 2, and then put that into f. So from there then, we're going to go f of minus 2, which will be 3 times minus 2 minus 5, which is negative 11. So you see there, we got the same answer for both of them. You take your pick as to which way you would like to solve. They both work, they both give you the same answer. It just comes down to personal preference. Now part E, we have f o g of x. Now I would do this in 2 separate parts. So we do the g of f first, so always start with the letter close to the x, so the g, that's going to go into f, and then that will then all go into f again. So f of g we've actually already worked out in part A, which is 3x squared plus 6x minus 8. Now we just need to put that into f. So it'll be 3 times 3x squared plus 6x minus 8 minus 5. And then simplify 9x squared plus 18x minus 24 minus 5, which will be minus 29. Then the last one, we want FOGOH at 1. So what I'm going to do with this one, start with the letter closest to the number or the x, which is h. We're going to start with h first. So first of all, we want to do h at 1. Now h is just -3, so at 1 that will also equal -3. Then we'll do g at -3, so we go to the next letter backwards, which is g. So g at -3 would be -3 squared plus 2 times -3 minus 1, which gives us 9 minus 6 minus 1, which equals 2, and then we can do f at 2, which would be 3 times by 2 minus 5, which equals 1. And that's how composite functions work.